Welcome back to Maths with Mrs. J. Just talking about area between a curve and the x-axis, a little bit longer just to make sure that the message gets through. So what we've got here is a picture of some random curve, doesn't really matter what it is. And if we were asked to find the area between the curve and the x-axis between x equals a and x equals c, what we would need to do for that particular curve would be to draw a sketch of it. Doesn't need to be particularly fancy. What we need to know is, where does it cross the x-axis? Does it cross the x-axis between those two values, a and c? In this case, it does. Any bits that are below the x-axis will come out as a negative when you're doing your definite integral. So what you'll need to do is put absolute value over that, around that, to turn it into a positive value, because obviously we're talking about area, so it can't be negative. Or what you can actually do is you can swap your a and b around. If you know that's going to be a negative definite integral, which it will be because it's underneath the x-axis, so from a to b will be negative, so from b to a will be positive. So that's probably the easiest way of doing it. This area here is just straight out from b to c of your function. And obviously your total area, you'll add them up. With our sine of x curve, we were able to really just do twice from 0 to pi because we know that it's the areas are the same, right? It's not always going to be that case, so we would need to divide it up into its sections. All right, let's have a look at one final example. If I wanted to draw the curve of this, first of all, let's just think about our x-intercept occurs when y is 0. So 2 equals e to the x. So x is obviously natural log of 2. Now, if you use your calculator to get an approximation for natural log of 2, you'll get about 0.7. So it certainly is relevant in the domain that we're talking about, from 0 to 2. So if we were to mark in 1 and 2, natural log of 2 will be about there. Your y-intercept, of course, occurs when x is 0. So y is going to be e to the 0 minus 2. E to the 0 is 1. So it's going to be at -1. I'm going to put it quite close to there because an exponential function is going to grow quite quickly. So we're going to need to do something like that for our area. I'm just going to colour it in orange. So we've got this bit here, and then we've got this section here. All right, and this value here that is crucial to know is natural log of 2. So what we need to do in this case, if we're going to calculate this area, so the area required will be from 0 to natural log of 2 of our e to the x minus 2 dx, but an absolute value of that. Now, it's probably easier, to be honest, to just swap that, and then that will automatically change from a negative to a positive. So do it this way and you won't have to worry about your absolute value signs. Plus, from natural log up to 2, that's all above the axis, so we're all good there. Okay, what is the integral of e to the x minus 2? Well, it's e to the x minus 2x. And we've got these bits that we need to substitute in here. So same integral here, of course. So we're going to get e to the 0 minus 2 times 0 minus e to the natural log of 2 is going to be 2, isn't it? You're doing an inverse function, so it'll be 2 minus 2 times natural log 2 plus this will be e to the e squared minus 4 minus, well, same thing again, so we've got 2 minus 2 natural log 2. All right, let's. Okay, so what do we have? So that's 1 minus 2 plus 2 natural log 2 plus e squared minus 4 minus 2 plus 2 natural log 2. So we've got 4 natural log 2 plus e squared, and then 1 minus 2, negative 1 minus 4, negative 5, minus 7. So that should be your answer, and that will be in square units. You can use a calculator to get an approximation if you must, but it's not really necessary. You can just leave it as that exact answer.